In this lesson, we will discuss the history leading up to the quantum theory for describing electrons in atoms. For many years, Bohr's model of the hydrogen atom was thought to be accurate because it accounted for many experimental observations. There were, however, multiple things that Bohr's model didn't account for. For example, Bohr's model couldn't be extended to other atoms. As well, Bohr made an assumption from his model that the angular momentum of the electron, that is the momentum from its circular motion, was quantized. But he did this with no explanation. These inconsistencies made it clear that there was something fundamentally wrong with Bohr's model and called for more research. This is where the famous physicist Erwin Schrodinger came in. Schrodinger realized that any equation describing the behavior of the electron in the hydrogen atom must take two very important things into consideration. Firstly, that the electron exhibits a wave-particle duality. From experiments carried out by a scientist by the name of de Broglie, it was discovered that electrons are neither fully particles nor fully waves. Instead, there's some sort of in-between. Secondly, Schrodinger knew he had to take into consideration that the exact behavior of the electron can't be known. From the work of Werner Heisenberg, the Heisenberg uncertainty principle was brought to light. It stated that it's impossible to know simultaneously both the momentum and position of a particle. Thus, we can never know the exact trajectory of a particle. Thus, we must instead focus on what the most probable behavior is. These two thoughts came together to form Schrodinger's equation, which is now the most accurate depiction we have of the behavior of electrons.